Good morning everyone. Welcome to Microwave Engineering video series. In the last video, we have seen E-plane T and its properties, and we also seen the derivation part for S parameter matrix or S matrix for a E-plane T. And we have understood different cases of giving input signals and its corresponding output by means of the matrix. And in the today's class, we are going to see what is H-plane T, how it looks, and what are the properties of H-plane T and its operation, and the derivation for scattering matrix. And at the end of the video, we are also going to see the similarities and the differences between E-plane and H-plane T. So let's start today's video. So this is the structure of H-plane T, which is similar to the E-plane T, where we are having three ports, that is port number 1, port number 2. So this is a single main waveguide. So these two arms, port 1 and port 2 arms, are called as collinear arm. And the third port is named as side arm or H arm. So a H-plane T junction is formed by cutting a rectangular slot along the width of the main waveguide. So in this figure, this is the main waveguide. So along the width of the main waveguide, so if you cut a rectangular slot and attach another waveguide, that means attaching this particular side arm, then this H-plane T will be formed. So in this particular H-plane T, the axis of the side arm is parallel to the magnetic field, that is H field. So to understand the power divisions in case of E-plane T, so we have seen that if input is given at port number 3, equal magnitude was observed across port number 1 and port number 2 with out of phase. So in the similar way, so we are going to understand what are the properties of power distribution and what about the phase. So suppose if you are giving input at port number 3, and suppose let's assume P is the power at the input, and P by 2 will be goes to the port number 1 output, and P by 2 will goes to the P by 2 output. So the main difference is the output power across port 1 and port 2 will be in phase with the input signal. So this was not in the previous case, that is E-plane T. In case of E-plane T, port 1 and port 3 are in phase and port 2 and port 3 are out of phase. But in this case, both port 1 and 3 and port 2 and 3 are in phase to each other. So here, so since both are in phase to each other, and since we are applying input at port number 3, so we can write S13. S13 means, so already we have discussed S13 means this 1 indicates output and this 3 indicates input. So since we are giving input at port number 3, so we are going to find at port number 1 and at port number 2. So that means I am going to have S13 between 1 and 3, and between 2 and 3 I am going to measure at the port number 2 by giving at 3. So that will be our S23. So both are having equal magnitude and both are in phase to each other. So we can write S13 is equal to S23. And as we have already discussed, in case of E-plane T, only one port is perfectly matched. So when we have perfectly matched port, that means when we are giving input to that particular port, 0% power will be coming back towards the same port. That means there won't be any loss, that is perfectly matched. So similarly, in case of our H-plane T, port number 3 is perfectly matched. So that's why we are writing S33 is equal to 0. That means if you are giving input at port number 3, 0 power will come back as the output across port number 3. That means there won't be any reflections, 100% transmission. That is S33 is equal to 0. So this is a basic diagram of a H-plane T, and the port power distribution diagram, that is P will be split into P by 2 and P by 2 equal powers. And so I'm just reminding you, so in the last class we have said that the power which we are dealing here is a normalized power. Normalized power means finding the power across a unit ohm impedance or 1 ohm resistance. That means P is equal to V square or P is equal to I square. So now we are going to find out what is the S matrix for this particular H plane T. This H plane T is having a 3 port. So please remember, 3 ports means the matrix size will be 3 by 3. So in this S matrix of the H plane T, so since we are having 3 ports, so the size of the matrix is a square matrix of order 3 by 3. That means 3 rows and 3 columns will be there. So which is similar to the E plane T. So S11, S12, S13, S21, S22, S23, S31, S32, S33. So since we have considered that port number 3 is perfectly matched, so S33 will be 0, and also the collinear arms, that is port 1 and port 2, are having the equal amount of outputs with in phase component. That's why we can write S13 is equal to S23. S13 is equal to S23, and please remember this condition is valid if the collinear arms are having equal length. Equal length means, so we are talking about the length of these collinear arms. If you are having the equal, then this S13 is equal to S23, you will get it. And the next property of S matrix is, that is property of the symmetry, that is Sij is equal to Sji. By using this particular property, we can write S21 is equal to S12, S23 is equal to S32, S31 is equal to S13. So by substituting these conditions in the above S matrix, so the matrix becomes S is equal to S11, S12, S13. There is no change in the first row. Coming to second row, S21, actually it is S21, but based on the symmetric property, we can write S21 as S12. That's why it is S12. This is S22. This was earlier S31. Based on the symmetric property, we can write S13 is equal to S31. S31 is equal to S13. So that's what we have written here. And similarly, this is S31. So we have written S13. And this S13, so basically this is S23. S23 is already equal to S13. So from this particular condition, so we have got here S13, and S33 is equal to 0 because it's a perfectly matched port. And now we need to find what is the value of S11, S12, S13 and S22. So in order to find out the values of the S matrix parameters, so we can further apply the different properties of the S matrix. That is one of the important properties, unitary property, that is S into complex conjugate of S is equal to unit matrix, that is I. So we have considered this particular matrix here, the same matrix, and we have written its complex conjugate, that is S11 star, S12 star, S13 star and so on left hand side. On right hand side we have 1 0 0 0 1 0 0 0 1. So in order to get these values in this matrix, so we will simplify by taking R1 C1, that is first row and first column of these. But the first row, this is my first row and this is my first column. So if you multiply, you will get S11 into S11 star. In the last class we have seen S11 into S11 star can be written as mod S11 square. Similarly, S12 into S12 star is equal to mod S12 star. So those who are watching this video first time, so I recommend please visit the previous video where we have given the explanation how you will get S11 into S1 star is equal to mod S1 whole square. Okay. And similarly, S13 into S13 star can be written as mod S13 whole square is equal to 1. Likewise, R2 C2, that is second row, second column, third row, third column, we will get these three equations. So from this particular third equation, so we can write S13 whole square plus S13 whole square with modulus is equal to 1 can be written as 2 into S13 mod whole square is equal to 1 can be written as S13 is equal to 1 by root 2. So this is the important value. We have to use this value in the previous matrix. And also from the first equation and second equation, so we can equate equation 1 is equal to equation 2 because right hand side 1 and 1 are there. So this S12 and this S12 will cancel, and this S13 and this S13 will cancel, and we will be having mod S11 whole square is equal to mod S22 whole square. So which can be written as S11 is equal to S22. That is based on the property of unity. We have got the simplified versions in terms of the other S parameters. And next, by using the property of zero property of the S matrix, so we can multiply any row of the first matrix with complex conjugate of the S matrix with the summation is equal to 0. So for this we can use R3C1. R3C1 means row 3 and first column. So row 3 first column means, so we will be having row 3 first column means S13 into S11 star plus S13 into S12 star plus 0 into S13, that is 0, is equal to 0. So we will get S13 into S11 star plus S13 into S12 star is equal to 0. We can take S13 common, and if we take S13 common, we are going to get S13 into S11 star plus S12 star is equal to 0. So in this expression, this S13 cannot be 0 because S13 value already we have got as 1 by root 2. So S13 cannot be 0. So S11 star plus S12 star should be equal to 0. That means I will be getting S11 star is equal to minus S12 star, or we can write as S11 is equal to minus S12. So this is our equation number 4. So we can substitute this equation number 4 in the equation number 1 for further getting the other unknown values. So we can put this equation number 4 in equation number 1, that is replacing S11 with minus S12 or replacing S12 with minus S11. Then if you substitute here in this expression, equation number 1, that is first one is mod S11 whole square, same thing. Second one is mod S12 whole square, that means S12 modulus is S11, so we will get mod S11 whole square plus S13. Already we got S13 is equal to 1 by root 2, so that is modulus whole square, so we will get 1 by 2 is equal to 1. So from this we are going to get S11 is equal to 1 by 2. That means, so the summary is we got S33 is equal to 0 based on the perfectly matching port, and S13 is equal to S23 because port number 1 and port number 2 are in phase with the input port, that is port number 3. Next, S21 is equal to S12, S23 is equal to S32, S31 is equal to S13. This we have got based on the symmetric property. And next, by using the property of unity and the property of 0, we have got the values of S13 as 1 by root 2, and S11 is equal to S22, and S11 is equal to 1 by 2. So we can put all these values in our standard S matrix. Then we will get matrix as 1 by 2 minus 1 by 2, 1 by root 2 minus 1 by 2, 1 by 2, 1 by root 2, 1 by root 2, 1 by root 2 and 0. So this is the final S matrix for a 3-port H plane T. So further we can use this particular S matrix for finding the various possible output cases by giving different various input signals. So here, like in case of E plane T, so we can write output, that is matrix B is equal to matrix S into input matrix A, that is B is equal to B1, B2, B3 on left hand side. So right hand side S matrix is the same S matrix whatever we have got based on the derivation part, that we are going to use it here, and A can be written as A1, A2 and A3. So we can multiply this thing for getting B1, B2, B3 values here. So we can write B1 is equal to 1 by 2 into A1 minus 1 by 2 into A2 plus 1 by root 2 into A3. That is A1 by 2 minus A2 by 2 plus A3 by root 2. Similarly, B2 is equal to minus 1 by 2 into A1 plus 1 by 2 into A2 plus 1 by root 2 into A3. Similarly, B3 is equal to A1 by root 2 plus A2 by root 2 plus 0 into A3, that is 0. So these are the B1, B2, B3, which are outputs in terms of its input signals. So now we are going to see the output expressions by giving various input possibilities, that is input signals A1, A2 and A3. So for that, so here we have given two different cases. The first case is A3 is not equal to 0, A1 is equal to A2 is equal to 0. So what does it mean? A3 is not equal to 0 means port number 3 is given with some input. Port number 1 and port number 2 are not given any input, that is A1 is equal to 0 and A2 is equal to 0. So if you substitute these values in this, so we are going to get B1 is equal to, we are going to get A1, A2 are 0. So then B1 is equal to A3 by root 2, B2 is equal to A3 by root 2, comma B3 is equal to 0. So this is very, very important. When you are giving input at port number 3, then we are getting output across port number 3 is 0. And one more thing is, across port number 1 and port number 2, we are getting an equal outputs. A3 by root 2, A3 by root 2. That is first thing. Suppose let's assume, so instead of giving only one input, let's assume case number 2, where we are giving A1 is equal to A2 is equal to A. That means at port number 1, you are giving a signal with A magnitude, and port number 2 with a signal with A magnitude. And port number 3, you are not giving any input. That means only two inputs are giving, and third port you are not giving any input. So if you put these conditions in this particular expressions, so what we are going to get is, we are going to get, because A1 is equal to A2 is equal to A, so these two will cancel. And already A3 is equal to 0, so we'll get B1 is equal to 0, and similarly B2 is equal to 0. But B3 is equal to, what we are going to get is, A1 is A, A2 also A, so A by root 2 plus A by root, that means 2A by root 2 we are going to get. That means when you are giving inputs at port 1 and port 2 with equal magnitude, that is A and A, we are going to get output at port number 3, that is 2A by root 2. That is very, very important property. That is, H-plane T will act as a additive if equal inputs are given at port 1 and 2 with in phase. That is what we have got in the case number 2. That means if you are maintaining same signal, same magnitude at port number 1 and 2, then the output of the H-plane T at port number 3 will be the additive of those two signals. That is the important thing. So in this case, you have to make sure that the phase of port 1 and port 2 input should be in phase. That is important. Okay. So if you look at the conclusion, that is summary or the similarities or difference between E-plane and H-plane. So here, in case of E-plane T, we can use it as a 3 dB splitter, that is power distributed by half across each output terminal or each output port. Similarly for H-plane T, it is also work as a 3 dB splitter. So axis of the side arm is parallel to the E. So axis of side arm is parallel to E field in case of E-plane T. In case of H-plane T, axis of side arm is parallel to H field. So this we have seen in the E-plane as well as H-plane diagrams. So in case of E-plane T, so it's a voltage or a series junction because electric field divides in side arms. So in case of H-plane T, this is current or parallel or shunt junction because H field divides in side arms. So in case of E-plane T and H-plane T, port number 3 is perfectly matched. So in both the cases, you are going to have S33 is equal to 0 and here also S33 is equal to 0. So in case of E-plane T, so we have S13 is equal to minus S23 because we are going to have in phase between 1 and 3 and out of phase between 2 and 3. That's why we have S13 is equal to minus S23. And in case of H plane, both are going to maintain in phase. So we will get S13 is equal to plus S23. So in case of E plane T, so this can work as a subtractive if equal inputs are given. Similarly, in case of H plane T, this will act as a additive if equal inputs are applied. So this particular case we have seen under cases of giving different input signals like A1, A2 and A3. So we can use subtractive as a subtractive for E plane T, and we can use as a additive for the H plane T. So this is about E plane T and H plane T under T junctions. So in the next class, we are going to discuss what is the magic T, how it is going to look, and what are the properties of S matrix of the magic T, that we are going to continue in the next video. So thank you. Have a nice day.